Hello and welcome to Excel for Monitoring, presented by Energypedia Consult in cooperation with ICT4D.at, the Austrian Network for Information and Communication Technologies for Development. This video will support you in gaining Excel skills for monitoring. You will learn how to set up a spreadsheet-based monitoring structure for your development program. When dealing with monitoring data in the context of development programs, Microsoft Excel has a lot to offer. Excel gives a structured format for convenient data entry and input. It also enables quick data analysis by applying basic formulas or creating charts. Further, you can create customized dashboards or overviews with visualizations of datasets, thereby illustrating indicators and progress. In practice, as you might know, M&E officers are often confronted with large Excel spreadsheets with lots of data, which are often sent to the entire team by email with a request to update them. Such spreadsheets can be confusing, and there may be several different versions of a file being updated on numerous ends. We believe that M&E systems should be relevant and useful, with data structured in a way that informs decision-making and enables projects to prove and improve their impact. All in all, in order to fully make use of what Excel has to offer for results-based monitoring, it requires evolving from simple spreadsheets to a real tool. In order to achieve this, we believe that monitoring officers and those in similar positions must have enough ownership over and understanding of the monitoring tools they are using. That's why we created this online tutorial. Our team at Energypedia Consult is made up of IT and M&E experts, and for this course, we've drawn on our experience gained in over 10 years of developing and setting up Excel tools and web-based monitoring tools for our clients in order to improve their results-based monitoring processes. In this online training, we will present basic principles and formulas, as well as more intermediate features paired with examples from the field that will guide you in using Excel as an M&E tool. We want you to know how and when to apply formulas in the practical context of development cooperation. Part of our philosophy is that we don't use macros, Visual Basic, or Power BI. We won't cover more in-depth statistical analysis here either, so you should be able to follow along with the most basic Excel skills. If you do not yet know how to enter functions and formulas and do simple formatting, we recommend that you first become familiar with Excel by watching some of the many free basic tutorials out there online. This course is self-paced. In addition to following along with the video tutorial here, you're invited to actively apply the newly gained skills in our exercise file. Both the exercise and the solution file can be downloaded by following the link in the description. There you'll also find the links to a sample file of a real monitoring tool, which we'll be presenting here as well as a collection of the most useful functions in English, German, and French. Please feel free to pause this tutorial at any time to do the exercises on your own and come back later. If any questions remain unanswered or come up for you while doing the exercises on your own or applying them in practice, we invite you to join our live Q&A sessions. Energypedia Consult hosts the quarterly free webinar Introduction to Results Monitoring with Excel, which you can register for on our website following the link here in the slide. In the tutorial for Module 1, you will learn some basic skills that we'll be referring to later in the course so that we've got everyone on the same page. We'll show you how to use tables to sort, filter, and calculate, how to create relative, absolute, and mixed cell links, and how to name areas of cells. If you already feel confident about these basics, feel free to skip ahead to Module 2. This is the exercise file that you can also download by following the link in the description. First, I'm going to show you a very practical feature, which is how to format data as a table, create a total row, and then filter the data. Assume you have a project running that involves an initiative where you're offering, for example, sexual and reproductive health education, and you have a certain number of people that you want to reach in each village. Each village belongs to a different county of the respective country. This is a fictional name of a fictional list of villages and fictional numbers as well. And these are the number of people that you have reached in each village so far. Now, first of all, to format this data as a table, you will select all of the data. Under the Home tab, go here to Format as a Table and select any style that you'd like. I'm going to go with a light style here. I'll leave the box My Table Has Headers checked. And now you can see that I have these little arrows pointing down for each column, which will allow me to sort and filter as well. First, now we're going to calculate these empty columns though, so that I can show you some more features later. So in order to calculate the number of people remaining, we're going to take the people to be reached, which is our target, minus the current value. And now when I press enter, it will give us the results for the entire column. I don't have to copy and paste the formula and pull it down. Now for the percent of people reached, we're going to divide the number of people reached by the target, press enter, and this cell has now been formatted as a general cell. And if we want it to say percentage, we can go here and select the percent style or use the shortcut CTRL Shift and %. If we want to create a total row at the bottom, we click on any cell within our table, go to the Table Design tab that will then appear up here, and select Total Row. Now it will automatically generate a total, but not only that for you, you can use various functions, not only sum, also average, or maximum or minimum. Let's select average here because that makes more sense for percentage. And then when you select the other cells, you can actually do that for each column. So here, maybe I want the sum of total people remaining, and here the sum of total people to be reached. Now, the great thing about this is that the total row also works and adapts itself to any filter that we apply. So in the exercise here, we're supposed to set up a filter that shows us all villages where more than 50% of the target value has been reached. So we will select number filters here. There are many options to choose from. We want the greater than option. To create this custom filter, we will say greater than 0.5 because that is the equivalent of 50%. Click OK. And now anything that's 50% or below has been not removed from the table. It's just hidden. You can tell this by looking at the color of the rows here on the left. They're now blue and not black. And also you might be able to tell that instead of a small arrow, we now have a small arrow and a funnel next to it. And so that way when you're looking at somebody's new table, imagine someone sent you a file and they've formatted as a table. Just be aware if the funnel is present, that means there's an active filter, which you can also remove, clear filter from % reached. And we could also apply several filters at the same time. So for example, if it's just a text filter, you can even use these boxes here. Let's say I just want it to show me all places where we've reached more than 50% of our target value in County 1. And here's our result. So the data that is filtered is not deleted. And another thing you can take away from this is that the total row adapts to the filter. It is a very practical feature that also has some disadvantages, and sometimes it makes more sense for you to actually put your own functions into Excel to understand what is happening. And I will show you some cases where that applies in our further modules. Next, let's have a look at the difference between relative, absolute, and mixed cell references. Here our scenario is such that we have maybe conducted a survey in 3 countries amongst survey respondents of different age groups, and now we want to know how many survey respondents per county were reached. Of course, we can use the auto sum shortcut by pressing Alt, Shift, and the equal sign, and Excel will automatically know which areas to sum up, and we'll create the total. For demonstration purposes, I will manually select the cells to be added up, because what I want to show you is that when I create a formula with cell links that look like this, then they contain relative cell relations. So that means if this formula is then copied down, the cell values are automatically adjusted to the new position. By going into the formula bar, you can check that everything went down by 1 row. Now, sometimes this is not desired, and instead you want the formula to point at one particular cell. In these cases, we need to fix our formula by using the $sign. In this example here, we would like to calculate the dollar equivalent based on the exchange rate. So, how many dollars are 23 euros? In order to calculate this for the first row, I multiply the exchange rate times the euro value. So 23 euros are $28.29. Let's see what happens if I pull the formula down to copy and paste. 32 euros are $0. So what happened here, that's not correct obviously, is that because the formula contained relative cell links, it pulled this box down by 1 row and this box down by one row as well. We want this to happen because we want to know how much is the equivalent of 32 euros, but we would like this cell to be fixed. So by pressing F4 and then copying and pasting it down, I can check down here, is this formula correct? Yes, it is. So what we saw here is that it's really important to correct the first formula before moving it down. This little box here tells you what will happen if you press F4 several times. If you press F4 for the first time, the column and the row do not change when copied because the $sign appears in front of the row and the column. When you press F4 another time, the $sign is only in front of the row, so the row does not change when copied. And when F4 is pressed a third time, the column does not change when copied. So why might you need that? There are certain cases where mixed cell referencing is required. And this third exercise, where we're supposed to calculate the percentage of survey participants per age group for each county, is referring back to exercise number 1. Okay, so this is a bit small. I'm just going to cut out and paste this table up here so that I can zoom in and it'll be easier for you to see. All right, so to calculate the percentage of survey participants aged 18 to 35, I will divide the total amount of participants aged 18 to 35 by the total amount of participants in County A, and I can format as percent. And now let's see what happens if I copy and paste the formula to the right. We get an error message. So what happened here? Excel moved both of these selected cells to the right, and for our first parameter, this was actually correct. However, we want this value divided by the total of survey participants in County 1. So we're going to go back here and just see what happens if I fix the total. Right, so let's copy and paste it and to the side, and here we can check, yeah, it does add up to 100, so this worked. It is still dividing the amount of survey participants in this age group by the total amount of survey participants in this county. Now what happens if I copy and paste the formula down one row? It tells me that there were 128% of survey respondents in this age group. That can't be correct. So what happened here? Here we're still dividing it by the total in County 1, but we want this number divided by the total in County 2. So let's go back to our original formula and think about whether we need the column or the row to be fixed. Now, I don't want the column to shift to the right or to the left when I move the formula because the total is always going to be in column F, but I do want it to move down when I shift the formula down. So I am going to remove the $sign in front of the row, copy and paste it down, and now see if it worked. And it did. So this total column I just left here so that we could double check whether everything worked. It is at 100%, and here we can see that it's dividing this age group by the total in County 3. The last small topic that I'd like to mention in Module 1 is naming areas of cells. Excel allows you to define names for cells or areas of cells. And the cells that are defined as names are then equivalent to absolute references. So to define a new name, you have to first select the cells or the areas of cells, and then the name can be inserted here on the top left in the name box. Let's call this one survey. So now when you select these cells, you will see they're called survey. And if you had several of these tables on one sheet that you were referring to on another sheet, that could make things easier rather than always referring to the column and row areas. So when formatting as a table, by the way, this actually happens automatically. If I select all the values of the table, you will see here, this one's called Table 2. Here in Module 2, we're going to have a look at several aspects that are relevant to data input and management. Traditionally, data input is done by hand, and it's useful for entering text or smaller amounts of numeric data. Other forms of data input include data import or linking to external sources. And one thing that all of these options have in common is that you have to check the consistency of the data. Not only the values themselves, but also the data format must be kept consistent if you want to assure that the data processing will yield the expected result. Generally, with collaborative monitoring, all data should be structured in a manner that allows the user to immediately see where to enter what kind of data. Another important point is to make sure that data is only entered once. If the same data needs to be displayed in multiple places, it is best to link between data cells instead of creating redundant multiple entries of the same data. So in this tutorial for Module 2, we will show you how to set up data validation using different criteria and learn how to protect cells and spreadsheets. We will also demonstrate how to link to data from different Excel sources and how to import data from external sources. Imagine you want other people to enter data into your monitoring tool. And to avoid typos or potential errors, you want them to only enter data in a certain format. This is what we're going to do in exercise 1. We're going to look at different data validation settings that will only allow users to enter dates, numbers, or data from a drop-down list. The default setting in Excel is that any value is allowed in a cell. It is possible to allow only certain values to be entered into cells, and we can do this by going to the tab Data, Data Tools, select data validation, and under validation criteria, you can allow a date, time, text length, any value, whole numbers. Here we're going to choose to allow only dates. And now we could enter the start date and the end date here in this dialog box, but that would be very hidden. So you or someone less familiar with Excel might want to change something afterwards or update the tool a year from now and then not know where to find these settings. So our Excel philosophy is that these parameters should always be in cells because then the tool is easier to maintain. Here you can see that we've already prepared something in a very light font. Let me change the font so that you can see it here. So the start date is in this cell F7. Which I will just select here. And the end date is in cell G7. Now when I click OK, I will confirm. Now let's re-enter. Here we get this error message. The value doesn't match the data validation restrictions defined for this cell. You can also define the error alert. So by going again to data validation and selecting the tab error alert, I could create an error message that says something like the date you have entered is not in the selected range, or hello, please only enter dates between January 2023 and December 2023. And I could also define an input message so that when somebody selects the cell, they will automatically be told what is allowed. So here we're supposed to allow only numbers, and it's the same procedure. Here under data validation settings, I will select only whole numbers between a minimum of 1 and a maximum of 99. So for example, you want people to only be entering ages, and so anything between 0 and 99 or 1 and 99 is realistic, and nobody can then accidentally type in 100 or 1,000 instead of 10. So if I want to enter a higher value, or I accidentally type a 2 too much, then I get this error message again. But anything within the range is allowed. Excel also allows you to enter values by means of a drop-down menu. A use case example of this would be to create a drop-down menu that enables the user to select a weekday. This saves time since manual data entry isn't necessary anymore, and it also ensures that only values from the list of allowed values are entered. That way the tool remains lean and clean and typos from users are prevented. So we'll go back to data validation and choose the criteria list and select a source. This is our source of 4 options. And now the reason why this says list here and not the cell range from E11 to E14 is that prior to demonstrating this, here in the name field, we've actually already named these 4 options list. And this is a use case example of what I was demonstrating briefly at the end of the Module 1 tutorial, where it can just come in handy to have certain cell ranges named using the name field. We might imagine that you were wanting to create different drop-down boxes, so you might have a list that's called weekdays, and a list that says gender to choose from. So here we can now select any of these 4 options. One thing to pay attention to is that if you wish to add another option, this will not automatically appear in the drop-down list. So you would either have to go back to the data validation criteria window and select this as the new source, or if your options don't necessarily have to be in a consecutive order, you could insert a cell in the middle of the list let's call this option 2A. And this will then automatically be added to your drop-down menu. So I'm going to just undo what we did so that we can go back to see what exercise 2 is all about. Okay, so here it says that next we're going to protect cells in this spreadsheet. So sometimes it can be advisable to restrict certain working steps to more experienced users and block some cells for less experienced users by using the Protect feature, which is here under the Review tab. To prevent users responsible for data input from accidentally changing the structure or even formulas in your sheet, you can protect either the entire worksheet or individual cells. So here the task is to protect all cells except for these gray ones. So the default setting is that when I protect this worksheet, all cells are going to be locked. And so this is why when you go to any cell in your worksheet, right-click Format Cells and go to here the tab Protection, you will see that it is locked by default. Of course, they're currently not locked. This only applies if you click Protect Sheet or Protect Workbook. And now if you want certain cells to be exempt, you will first right-click the exempted cells or the cells to be exempted, and then we'll uncheck the locked box. I'm going to do that for all 3 light gray cells here. And now when I click on Protect Sheet, I could also set a password. Now, if I try and enter data into any cell, let's say I'm going to double click, I will get this message. If I try and enter data in the light gray cells, it's still possible though. A big advantage that Excel has to offer is that it allows you to link different spreadsheets with each other. That way, you can summarize data from subordinated sheets, such as individual pages for each component of a project, on an overview sheet. At the same time, the possibility of linking cells across different sheets helps avoid redundancies, as information from one sheet is imported to another sheet and doesn't need to be re-entered there. Here in exercise 1, I'm going to demonstrate how to link to a cell from another spreadsheet within the same file. Here, all the way to the right, we have the tab Monitoring Data. Let me show you. There's a table that we're just going to draw some information from. Imagine that we were calculating and we needed the expenses here in region 1. So we are going to go back to our tab, Data Importing. We put in the equal sign, head over to Monitoring Data, select the cell that you would like to refer to, and press Enter. And now you can see that in simple quotation marks, it is referring to the tab Monitoring Data and to the respective cell there. In the same way that you can link cells within an Excel sheet or between different spreadsheets of the same file, links can also be established between cells from different Excel files from the same computer or shared network drive, for example, a common server or a Dropbox. This is particularly useful for projects where individual project components maintain their own monitoring tool. Each of their subordinated sheets can be linked to the overall project manager's overview sheet, where the data is then summarized. Or perhaps you have an Excel system with one master file and several data entry files. And then, of course, you can design these data entry files to look more like questionnaires using sheet protection and data validation so that users can only enter specific data. Again, this way you help avoid redundancies, as information from one sheet is imported and doesn't have to be re-entered. So in this exercise, I will show you how to link to cells in a separate Excel file. I'm now going to open a new blank worksheet. Here under File, New, Blank Workbook. Suppose I would like to refer to this data from the other file and have it appear here in this cell of the master file. In our new file, I will use cell A1 as an example, and I will put in the value 1000. And now I will link to this cell in the master file by using the equal sign, moving to the other window, and selecting A1. You can already see the formula up here. Book 1, Sheet 1 is the name. Because I haven't saved this file under a different name, it is automatically called Book 1, Sheet 1, and then referring to a cell. And in this case, you can see the cell is automatically fixed with the dollar signs. And if both files are open, and I'll now save and rename this new file, it will also change the name in the formula of the receiving file. So let me go ahead and save this file under a new name. I'm going to call it sending file. And now, when I switch back to our exercise file, you can see that it has automatically adopted the new file name. The same is true if I rename this sheet here, for example. So the default name is Sheet 1. If I right-click and rename it to Sending Data, go back to our exercise file, it's also adopted the new sheet name. However, if the file from which the data is pulled is closed and someone else renames the file or moves it to another folder, then the cell relation between the files will be broken. So this only works if both of these files are open at the same time. Otherwise, the receiving file wouldn't be able to find the sending file anymore, and then you'd have a problem. So this is the weakness of these types of Excel systems. It's still possible. Of course, there's workarounds. You can repair it if this happens and connect the files again, or very clearly communicate not to rename the interlinked Excel files and let other users know that the file's location may not be changed and to only enter and update data. Now let's look at semi-automatic data import. So besides the completely automatic way of data entry, data can also be imported semi-automatically. And the way to do this is to create a separate sheet within your Excel file, which you would then call the transfer sheet, the same way that we did here, all the way on the far end with monitoring data, which will then contain the data from your external sources. This could, for example, be data from the web, for example, statistics from the OECD, or WASH data, which we will have a look at soon. Or another example would be data from your accounting software. So if financial aspects need to be regarded in your monitoring, such as cost efficiency or the value for money approach, it's rather easy to integrate financial data from accounting software into an Excel-based monitoring tool. You just save the desired data as an Excel or CSV file, select and copy the data in that file, and then create an extra sheet in your monitoring tool, which you will then call the transfer sheet, and paste the data. And now your sheet with financial data or statistics from the internet can be linked to your current project values and expenditures. And I'm just going to demonstrate this using some statistical data from this WASH website here. I will download the Household World file, open it here. So here's data from the Joint Monitoring Program for Water Supply, Sanitation, and Hygiene. And let's just say I need this data to refer to in my calculations. So I'm going to just copy this for demonstration purposes. Now, when you go back to your Excel file, you start a new sheet. You rename it, we'll just call it external data, and paste it. And my main point is just that when you do copy and paste external data, always choose the same place in your external data or transfer sheet file. So if I was to copy and paste it in A1 and have the entire table start here, then if I go back a year from now to get the data for year 2021 and I want my cells to still be referring to the same spots in this table, just make sure to always paste it in the same place again. Now that we've looked at some aspects regarding raw data entry, it is time for data processing to begin. In order to obtain the desired information regarding progress as well as results and impacts of a project, the entered data will be modified and recombined. In this module, number 3, we will introduce you to some of the most important Excel functions for obtaining information regarding progress, results, and project impact. Here we're going to have a look at the functions related to dates, such as today, year, and month. The function today offers many more possibilities than the simple output of today's date. Just like all other Excel functions, it is mainly the possibility of combining functions with other functions that raises the usefulness of this function far beyond the use of the individual function itself. Imagine you're involved in a project and want to know how many days are left until the end of the project term, in order to assess whether it's realistic to achieve a certain result by then, for example. Or perhaps you're responsible for financial monitoring. You have a set budget and are asking yourself, how much do we need to spend on average until the end of the year to fully use up that budget? In order to calculate with dates, the first step is to let Excel generate your current date. We do this by selecting a cell and using the function today. So we're going to open the function with the equal sign. As always, enter the function today and leave the brackets empty. Press return to confirm, and it will give you today's date in the day, month, year sequence, regardless of when you open the workbook. For other country settings, the default format may be month, day, year. So when you do this exercise on your own, of course, it'll show you a different date than this one here. Now, if you want to know how many days are left until the end of the year, start a formula by putting in the equal sign. Then select this day, which is New Year's Eve, the end of the year, minus today's date. Press enter to confirm, and the difference is now the amount of days until New Year's Eve. Once again, we're calculating with values that are already in cells. And of course, if this was bothering you, you could make the font white. But again, we recommend keeping things visible so that you could then next year change the date to 2024. Now, if you don't want to calculate with days, just with months, you can use the formula month. Type in the equal sign, formula month, choose the date in this cell, B18, close the brackets and press enter, and there it'll give you the month of the selected date. If you grab the cell in the lower right corner and just move it down, you can copy and paste it to other rows. Now if you change the date, you'll see the month changes as well. The same can be done for year, for the formula year, which then returns the year of the selected date. Once again, I can change the year and it will automatically update here as well. Now for exercise 2b, let's imagine you have a table with a column heading balance and then the current month and year. And you have a list of data below your heading. And then the next month you receive new data and want the headline to change accordingly. Ideally, this would happen automatically rather than manually in order to minimize the amount of maintenance work you have to put into your Excel tool. So instead of having to remember to change the heading once the next month comes around, we will create a formula that does this for us. I can add text to a formula by adding quotation marks. Now for each new element of the formula, we need to add an and sign. Next, we want the month and then in quotation marks again, the slash, because the slash is going to be static. That's never going to change. We add another and sign and select the year that we'd like this formula to refer to. We press enter, and here we have a dynamic cell contents that will change when the next month rolls around. Let me change this to April. And here you can see that it is automatically updated. Now, if you've been paying attention in the last modules, you will notice that we have some text in a formula, and that's something that we've said we want to avoid, because anybody who does not know the exact setup of a formula like this might accidentally remove some quotation marks if they wanted to change the word balance to budget, for example. And so again, it's best to use text that is already in cells, which we've prepared here. So instead of the word balance, we're going to refer to the cell E24 that contains the word budget. And we will want an empty space between the word budget and our date. I'm just going to leave the colon away. So I added an and sign, and again, the upper quotation marks for whatever is static in the formula, and then just a space in between, and another quotation mark to close that static area. The and sign for the next element, which is still the month, the and sign for the static element, which is the slash, and then again the and sign for the year. And now if I wanted to call this balance again, it would automatically update as well. We have a very clean and lean formula that doesn't have any text in the cells. In this next sheet, we will be covering the functions if, SUMIF, and COUNTIF. In the first exercise, compare the actual value with the threshold value. You're supposed to generate a formula that will display the words over 100 if the actual value is above the threshold and below 100 if it is below. In practice, for example, this allows you to trigger an Excel cell to make a statement on whether the expenditures of a project exceed the planned budget or not. I'm going to open the formula if, and here in this window, it already tells us what the function does. If checks whether a condition is met and returns one value if true and another value if false. And now I open the brackets, and first it is asking us for the logical test. So we're testing whether D9 is larger than E9. And if this is true, semicolon, value if true, I want it to return the words over 100. And if it's false, I want it to return the words below 100. So this needs to be in quotation marks. Here we go. Of course, in this example, it's not hard for you to decide whether this value is above or below 100, but if you have an entire list, it gets more complex. And then, of course, a formula that calculates lots of data for you will support your work. And as we've already said, we want to create a tool that's easy to manage. So what if the threshold value changes next year? Say it's raised to 110 and our function still returns the value below 100. Well, that would be true, but it would look strange because the threshold value would be at 110. So as always, we've already prepared something here in these light gray, in this light gray font. It says below and over 100. And now I can also replace the text in the formula with these cells by just referring to these cells. It's already a bit better, but still not optimal, because now we would still manually have to change this field to below 110 and over 110 if our threshold value changes. It would be even better if in these fields we had a formula that automatically adapted itself to whatever threshold value we put into this cell. So back when we worked with dates, we learned that we can connect content, like words, and cells with the and sign here. So we're going to create a formula with the equal sign where the word below is in quotation marks. Then we add the and sign and refer to the threshold value. Actually, I need a space in here. And the same we can do over here. It's going to say over and the threshold value. So now I can raise the threshold value and it'll automatically change these cells here, which this formula here is referring to. Exercise B is similar, but instead of above or below the threshold, we want it to say yes if it is larger or equal to the threshold value, otherwise it should say no. So here we've prepared our text in our cells, and the function here is if D11 is larger or equal to E11, it will say yes, otherwise it will say no. So no, 40 is not greater than 150. So this threshold value cell, you can tell here, is referring to this threshold value. We only have to enter it once. Let's go back to 100. So what if it said 100 equal? It says yes, so everything worked. Next, we're going to look at the function SUMIF. That means I want Excel to create the sum of a set of values if a certain condition or criterion is fulfilled. SUMIF searches the specified area for the given search criterion and then adds up the numbers from the sum area next to it. This allows you, for example, to add up how many people were reached in each of these regions. This could be the number of people trained or the number of beneficiaries. Here we called it number of people reached. And you're also spending money in these regions. And now you have a list where each row is attributed to some region, but it's not sorted by region. And in practice, of course, this list could be much longer. And now we want to know for each region how many people are connected and how much money you spent. Now, if you paid attention in Module 1, you might know that there's an easy way to solve this by formatting as a table and then just creating a filter to show me all rows with, for example, the region of Africa, and then creating a total row that will just sum up the values. Then I could copy or just manually insert the values in this list. Now, the problem is, though, that if these values were to change, it wouldn't automatically adjust here in our results. But say that the number of people reached increases with time because we're still working in certain, it's not a project that's completed yet. Our expenses are raised as well. We would want that to be reflected here in the cells that are displaying the sums for each region. So that's the disadvantage of using the format as a table function, and that is why in this case we're going to actually apply the formula SUMIF. So when you type in the formula SUMIF, the first parameter that it's going to ask you for is the range. This is the area where Excel is supposed to look for the search criterion. It is the range of cells to be filtered. That's an easy way to remember it. See, if we were using the format as a table way of solving this problem, then we would have easily thought of just filtering the region column so that it will only display Africa here. Next, then after the comma, or for you it might be a semicolon or a comma, depending on which country you're in, the next parameter is the search criterion. This is what we're looking for in this range of cells. We're looking for Africa. Make sure that this cell is identical with the list, especially in spelling. So if this cell said Africa with a lowercase a, Excel would not be able to recognize it in this range. I could, of course, also put Africa in quotation marks here into the formula, but as I've explained, we prefer not to have any words in our formulas, only cells. So in this row number 26, I want to have the sum of all people reached in Africa, which means that the next parameter is the sum range. This is the column of the table that we're adding up. And I want Excel to sum up this range here if this criterion is true. Then I close the brackets, and this gives me the number for Africa. Now I'd also like to copy and paste this formula because the logic is the same for the other cells and for the other regions. Just that in the rows below, I want the search criteria to be Asia and Latin America and not Africa. And here in the cells to the right, I don't want it to sum up the number of people reached, but the expenses. But be aware, if you take this formula and copy it one row below, all of these references will also move down by one row. In this case, it's not tragic because Africa was already covered here in our first formula, but of course, that's no guarantee. So we're going to apply what we learned in Module 1 about absolute and relative cell lengths. We can always choose whether to only fix the row or the column or both. So now we have to think about it. Here we can see that the range is always going to be the same. We always want Excel to look for our criterion within this list of regions. It should never move down or to the right or to the left. So we can fix the range here by pressing F4 or adding the dollar signs manually, of course. As for the search criterion, the region, if I copy the formula one row down, it should take the next criterion. But I don't want it to switch to the right if I copy the formula to the right. I want it to continue to stay in column C and not move to column D. So I need to fix the columns only. And I can do this by pressing F4 3 times. As for the sum range, we do not want this to move down, but we do want it to move to the right when we're asking for the sum of expenses. So I will only fix the rows and not the columns so that we can switch to the right by pressing F4 twice for this range. So that means I can now copy and paste the formula down and to the right. And if I want this to appear as a specific format, a currency, or accounting, for it to look the same, I can go here under the Home tab to Numbers and select what I'm looking for in this drop-down menu. Exercise 3, sum if using data from another spreadsheet, is basically the same as exercise 2, except that the data is in another spreadsheet in the same workbook. So for this exercise, we're going to refer to the tab monitoring data. And in the same way as above, I can refer to the data in this table for my SUMIF formula, just that now the range is somewhere else. So first I'm going to open the function, SUMIF, open the bracket, then go to the sheet, monitoring data, to select the range. And you will see that up here in the formula bar, it is also telling me that the range that I selected is in this other sheet. Now it's important to close the first parameter with a comma or a semicolon, depending on your version of Excel, because otherwise when I go back to the comparisons and sums sheet, it would think that I accidentally selected data from the wrong sheet and it would overwrite it. So now that I'm back here, I can select the criterion, put in a semicolon, and then go to the sum range on the monitoring data sheet. Now I'm going to close the formula. So what went wrong here? I'm actually giving you the perfect unintentional example of what I was just explaining, that it's important to either close the parameter or the formula while you're in the other sheet. Otherwise, Excel will think that you were just accidentally choosing data from the other sheet, and it automatically switched back to comparisons and sums. So let's correct that. Go back to monitoring data, select the sum range, close the formula here, press enter, and here we have our solution. So now we are going to just have to, in order to copy and paste the formula, go through the same procedure as earlier, where here we fix for the range, we fix the rows and the columns. For the criterion, we only need to fix the column. And for the sum range, it was the exact opposite. I am only going to fix the rows and not the column. Now I can copy and paste the formula as we did before. Now, why are these values slightly different? I think it's because the monitoring data here is slightly different than in our table. Yeah. So nothing to worry about. Everything worked. In exercise 4, we will learn how to count something using the function COUNTIF. With COUNTIF, the amount of non-empty cells of an area can be determined which match a specified criterion. So here we'd like to know how many times each region can be found in our list of sites. I'm going to start the function COUNTIF, refer to this range, the list of sites, close this parameter, and refer to the criterion, which is the respective region. It returns 4, which means that this region is in the list 4 times. 1, 2, 3, 4. It's a short list, so we can verify that. And now let me show you what happens if I move the list down without fixing it first. You can see here that the range has moved down by 1 row, and it doesn't include the first row of the list anymore. So again, I'm going to go back to our original formula and fix the range. So that I can copy and paste it. In our next tab, Sorted Lists, the goal is to create a table displaying the most cost-intensive countries and their respective costs. So the goal is right here at the bottom. This is what we're working towards, the top 3 countries and the top 3 costs. Other practical examples of ranks and sorted lists might be top countries in terms of beneficiaries or people reached, and so on. There are many ways of doing this. One is using pivot tables, which automatically generate sortable lists. We'll give you an introduction to pivot tables later on in this module. And of course, we learned that we could format this as a table and then sort largest to smallest. Here, let's sort the costs smallest to largest, and so we can actually we could just refer to these top 3 countries here in our final table. So the issue here is that we might still be in the middle of a project cycle in all of these countries, and so the costs can vary with time. However, we'd like our top 3 list to always be reflecting the current status. Imagine we had a management cockpit, a dashboard that was only displaying this top 3 list with the respective data in other sheets in the background. So there's a better way of solving this, because this would involve you regularly going back to this table and remembering to sort smallest to largest so that you always have the current top 3 in your dashboard. And there's a way of doing this automatically, though. We could also do this and go straight to exercise 1C and solve it all in one big formula, but we're going to do it step by step so that you can understand the process. In the first exercise, exercise 1A, we're going to filter the 3 highest values from the table above by using the formula large. The formula large returns the kth largest value in the data set, for example, the 5th largest number, the 3rd largest number. What it's asking for first is an array, and I will select this array here. And then the k parameter refers to the 1st, 2nd, 3rd largest value. I could put a 1 here, but since I have this number here, I'm going to select the cell and just see if this is going to work. Now it's giving me an error message. So if I'd rather have my values in cells, I have to remove the dot, and now our formula works. The advantage of, again, of not having numbers or text in our formulas is that if I decided that I'd rather have the 1st, 2nd, and 5th largest value, all I would have to do is change the number here and not in the formula. To copy the formula, we want the parameter k to change, but we don't want the array to move down, because as you can see here, it wouldn't include the entire list of costs anymore. So I will not fix the parameter, but I will fix the array. So here we have the top 3 costs, the 1st, the 2nd, the 3rd highest value. Now you might have noticed here this little box that says that if 2 values are equal, you have to create dummy values for the large function to work. This might be true for your version of Excel. In my version of Excel 2016, I can actually have identical values. So let's say the costs in Honduras go up to 11,000, and then this is actually reflected in the table. It is displaying 11,000 twice. I know that that hasn't always been the case with Excel, so I'm just going to show you this workaround by means of creating dummy values. So what we would do is we would create a row that displays these costs plus a fraction of the row number so that they would all be unique values. So what does this mean? I will take the costs and add the row with empty brackets divided, because if I was just to add the row, it would add up to 5,007. So I'm going to divide the row number by a very large value so that we have a tiny fraction at the end here. And I'm going to do these for all of these values. And then here in our large function, we could actually refer to this array instead, and it would still display 11,000 here. But if you were to add the comma, you would actually see that it's in fact referring to these dummy values. But even if you were to do further calculations using these numbers, because it is just such a small fraction, it wouldn't actually change anything substantial for you. Let me just undo this so that we have our old values again. Now we know what the top 3 costs are, but we do not yet know which countries they're occurring in. And that means we need a formula that returns from the column country the name Rwanda if the value is 11,000. Now you might think that we could use the sum if formula, but this one only works for numbers and it wouldn't be able to return text. Luckily though, there is a formula for matchmaking. Again, I could do this all in one formula, but I will demonstrate step by step. The question here now is which row within this matrix, say this is row 1, and then this is row 2, 3, 4, 5, 6, 7, and so on, does the number 11,000 occur? So the function match looks up the value and returns the row number. So I'm going to tell it to look up the value 11,000 in this lookup array. Remember, we're working with the dummy values right now. And then it'll give me some options for match type. I want the exact match. And so it's telling me that the value 11,000 is in row 8 within the lookup array. So let's verify. 1, 2, 3, 4, 5, 6, 7, 8. That's correct. Again, I need the formula to work for the other cost values as well. The value that I'm looking up should change. That's C21. But the area, the lookup array, should stay the same. So I'm going to fix it using F4. And now I can copy and paste it down. I see. I hadn't yet copied and pasted the large formula that's referring to the dummy values to the other rows. Now we're in the correct lookup array. Now let's see if we can use these row numbers to find the country with the index function. The index function returns a value or the reference to a value from within a table or a range. We are going to be searching within the column of country names, that's our array, for row number 8, which was our return of the match function. And the column is the list with the names of countries. In this case, it is column, we'll call it column number 1. I could also call it column number 0. That would work. And in order to copy and paste it, again, I have to fix the array and pull it down. Now we can verify, yep, the 11,000 top number 1 costs were in Rwanda, the 10,000 were in Senegal, and the 9,000 were in Mali. And now here in exercise 3, I'm just going to be referring. So here, it's just simple cell references to the other tables that we've just created. And in practice, this table, as I said, might be on a different sheet called a dashboard or a country overview page. And now I have a dynamic table of the top 3 costs per country. Now we've reached Module 4, Data Output and Visualization, our last module. Classically, Excel is used to show results in a simple table. Of course, tables are an appropriate tool for the presentation and organization of data. However, they often tend to be confusing, and it takes a long time to find specific data or to extract the desired information from a large data set. An appealing visualization of the data instead offers substantial advantages in the communication of important information. Visually optimized data output helps users to quickly gain an overview over the progress of a measure. During this step, technical knowledge of formulas or calculation methods is less important. What is needed instead is creativity in the choice of the optimal presentation format. The goal needs to be that decision makers and also external persons are able to understand and process important information in a short amount of time. In this module, you'll learn how to bring meaning to data using conditional formatting. You'll also learn how to visualize qualitative and quantitative indicator progress using traffic lights and drop-down boxes. We will also learn how to make clever choices of diagrams so that you don't even need legends for explaining them and can free your data output from unnecessary information. We'll also introduce you to pivot tables and charts. Finally, some of the elements we covered will be summarized in a management cockpit, a creative and fun way to display all of your most important data and progress at a glance. In our real-life example, we will show you a monitoring tool that makes use of many functions and data visualization techniques that we covered in this course. Let's start by having a look at some simple conditional formatting to help bring meaning to data. A good option is always to set up formatting that automatically adjusts itself when values change. A simple example would be to switch the background color of a cell to red if its value exceeds a specific benchmark, or for the cell to change their color to green, yellow, or red depending on the degree of target achievement. Here in this exercise, we have a data set from 2022, for example, from a survey, and a data set from 2023, and we would like to see if anything has changed over the year. So in order to set up conditional formatting, we have to go to the menu tab, Home, go to Conditional Formatting, and then choose from one of the many rules. We're going to say greater than, and I want it to be a green fill with dark green text if the number has increased since the year before. As you can see, Excel has automatically added the dollar signs and fixed this cell. So if I were to copy and paste this rule, it would always be comparing each of these values to this one cell. So I will just go here and manually delete the dollar signs. Now to copy the rule for conditional formatting to other cells, do not drag the black cross as if you were to copy formulas, because as you can see, otherwise it would just transfer the cell values and overwrite the other cells. So let's undo that. Instead, go to the Format Painter here under the Home tab, which is the paintbrush on the top left. Select the cell which already contains the conditional formatting rule that you set up. Click on the paintbrush, and now paste it to the entire table. And now we can tell at a glance in which areas something has changed in the course of the year. Of course, this is a very generalized example that can have many practical application scenarios. Next, we're going to have a look at visualizations using color scales and traffic lights. Excel allows you to highlight successful projects at a glance using these color scales to be found under conditional formatting. Of course, you're the one to decide whether a higher or a lower value is to be considered successful. So in this case here, green is automatically applied to higher values within the cell range, and red means it's a lower value. You can also have it the other way around, where red is the highest value, or use different color gradients. You can also use icon sets, and then you can tell at a glance that Project 1, Project 6, and Project 7 are the most successful in terms of these numbers. We recommend using shapes, though, in addition or instead of colors, because these will also be understood on black and white printouts and by colorblind people as well. When working with color scales, be aware that as a default setting, Excel is always working with percentiles. And you can change this also to be absolute numbers, either in percent or in numbers. Because otherwise, when these values change, and for example, let's say we don't have any lower values at all, anything that's below 40%, then all of a sudden the colors that were orange or yellow to begin with will turn red, because it's always just looking at because it's always comparing the numbers within the selected range of cells. If I wanted Excel to look more at the percentages in and of themselves rather than compare these values within the range and base its color gradient on the comparison, then I can select percent here rather than percentile. So that's a fine difference just to be aware of. Sometimes things aren't as linear as that, though. And you can't necessarily say that a higher value equals better progress than a lower number, or vice versa. In some cases, you might want to do the assessment on your own and visualize it so that you and others can quickly tell if there are any issues to be solved. So here in exercise 2A and B, we're going to have a look at customized indicator assessment. So in this exercise here, we are going to learn how to set a status in order to assess our indicator progress manually using drop-down boxes. This is something that we already covered earlier on in Module 2 when we were looking at data input. And if you remember, we will have to go to the Data tab, Data Validation, and select a list to choose from. We've already prepared a data source here. So these three options, on track, minor issues, and off track, are going to be our source. And now we can decide for ourselves whether this current status is on track or not. So let's see here. The target is that the discussion on sustainable wildlife management has started in the National Parliament. Currently, the topic is not yet on the official agenda, and only 3 key parliamentarians have become interested in it. I would say we definitely have some minor issues, if not off track here. Now let's copy and paste our drop-down box using the little black cross. For indicator number 2, our target is that a national law on hunting rights is passed. Currently, the law has been drafted, but is still being revised. And we could say, for example, yeah, this is on track. We weren't expecting it to be any further ahead. Now we're going to do the same for quantitative indicators, and in addition, we're going to be working with traffic light arrows to visually display the status. Again, we could create a formula that would, based on the achievement in percent, tell us whether we are on track or off track or have some minor issues, but sometimes certain indicators are more complex or more challenging. So it makes sense to do a manual assessment. So maybe progress of 10% here for indicator A isn't even that bad, because you've only just been measuring indicator A for half a year, and considering that time frame, you wouldn't have expected more progress. Or maybe your project term ends in 5 years, and considering that, 10% progress might actually be quite good. But Excel would, of course, only be able to see the relatively low percentage of the achievement and judge it as slow progress. All right, so now we can say, yeah, actually, indicator A is on track. There's some minor issues with indicator B because we were expecting it to be even further ahead than 80%, and indicator C is off track. Now for our last column, arrow, where we would like to visually highlight whether the indicator is off track or on track, we are going to go back to conditional formatting and use these icon sets. Now, just selecting these 3 arrows is not going to do much for us because Excel needs numbers for this conditional formatting to work. So we can't just tell Excel to give us a green arrow if the cell says on track. So we will first have to ascribe numerical values to each of these statuses. The numerical value of 3 is going to mean on track, and 2 is a yellow arrow and 1 is a red arrow. So how do I get this cell down here to display the numerical value for on track? I'm going to show you how to do this using the SUMIF function. There are several ways. So first we need the range. This is our range of criteria. And our criterion is going to be whatever we've selected in our drop-down box here for the status of indicator A. And our sum range are these 3 values. Since there's only one number in this sum range per criteria, it won't actually add any values. It will just give me this single value, either the 3, the 2, or the 1. So now it's showing us a 3 here for on track. Now I need this formula for the other rows as well, and of course I could, if I would copy and paste it, all of the values here in the reference areas would go down by 1 row as well. So I'm going to fix our range. I'm going to leave the criteria because I do want that to move down by a row when I copy and paste it down by a row. And I'm going to fix the sum range as well. Now I can copy it down and I have the values corresponding to the chosen assessment. However, if I were only to choose minor issues and off track, for example, as you can tell, even though it still has the numerical value 2, the arrow is no longer yellow. This shouldn't be the case, but Excel is only checking for the largest and smallest values in terms of percentiles, which is why we want to define the threshold values as absolute numbers. So I showed you before how to go to the rules and manage the set of rules. Double click. And now we want to edit it. So you can see that Excel has automatically set threshold values and the default setting is %. So the lowest, 33%, is red, the middle is yellow, and the highest values are green. We only have 3 numbers though, and we want each of them to be assigned an arrow. So we're going to be working with numbers here. We're going to say if the value is equal to or larger than 3, show me a green arrow. If it is larger or equal to 2, show me a yellow arrow. And if it is below 2, well, it's going to show us a red arrow. Now we click OK to confirm. And here we can see that even if I choose minor issues and there is no indicator that is on track, the arrow is yellow and not green like before. And if I'd like to remove these numbers because maybe they're just confusing and we don't actually need them, we can go back to our rule set and just tick this box, show icon only. And now we just have a neat set of arrows. And again, this data visualization allows you to tell much faster if an indicator is off track or on track, especially because if you were to just scan this status column visually, the words on track and off track are so similar. So now when you see a red arrow, you can just quickly tell that there might be a need for intervention. Next, we're going to have a look at a simple form of a chart, which is the line chart. There are many forms of charts to choose from here. You could even ask Excel to recommend a good chart to showcase your data. But for now, the exercise, the task at hand is to create 3 line charts that display the development in each village in the course of the year. So the idea here is that I have a table with villages A, B, and C, and for these villages I have values between January and December 2022. For example, from a survey, or we could say this is the indicator monthly average income per village, and we'd like to visualize these values in the shape of a diagram. These line charts can be small, and they will show me at a glance how the values in each of the villages have developed over the year. Of course, I could choose to show all 3 villages in one diagram, but especially if there are several different aspects concerning one village, it makes sense to depict them separately. Creating these types of line charts is pretty easy. I select the data that I would like to display, choose a 2D line. Now let's just move this, make it a bit smaller. I don't need the exact months. I'm really just more interested in the general trend in the course of the year. Now when I click on the diagram, up here I can see which data it's referring to, village A. To copy and paste the diagram, I hold down the Control key and just pull to the right. And now I can pull the area that it's referring to down. So here we have a chart for village B now. However, part of our exercise was to create comparable line charts. And as you can see here, even just by looking at these horizontal lines, Excel has changed the scale of the y-axis, and now the 2 charts aren't comparable anymore. So we're going to create a step in between up here. We are going to have Excel tell us what the lowest value out of this entire range of data is and what the highest value is, so that we will know how to define the scale of our y-axis. And we will do so using the minimum function. We select the entire area, press return, and the same for the maximum. All right, so now we know that our y-axis should definitely include values between the minimum and the maximum, maybe even a bit below and a bit above these values, and it doesn't even have to necessarily include anything below 900. In order to format the y-axis, you select the axis on the chart, right-click, select Format Axis, and now we can edit our axis options. 900 is fine for me as the lowest value, but I'd like the maximum to be somewhere more around 1,800. I'd like the units to be a bit smaller in between. Now, this hasn't adopted our new settings to village B yet, so I'm going to delete that, and again, by holding the Control key down and the mouse button clicked, I can just pull the chart to the side to copy and paste, select the area, pull it down by 1 row, rename it to village B, and now you can see that instead of going back to its default setting, Excel is sticking with the y-axis that we've defined. And now we have 3 comparable charts. If we were really just interested in the trends, we could even remove the numbers on the y-axis and get very minimal here. Our main point is also to show you that you can dare to minimize information in your charts and even create pages with maybe about 20 different line charts for your various projects, and that would be an easy printout page and the beginning of something like a monitoring dashboard as well. Don't be afraid to really strip down your charts of any excess information so that you can tell at a glance what it is that you want to know. And here, for example, maybe all that I need to know is that, yeah, the trend for each village has been relatively constant. There were dips for village A, B, and C in the beginning of the year. The general average income is much higher in village B than in village A and village C. The exact numbers aren't as important to me. Now I'm going to show you how to create a pivot table. A pivot table is a table of grouped values that aggregates the individual items of a more extensive table within one or more discrete categories. This summary might include sums, averages, or other statistics, which the pivot table groups together using a chosen aggregation function applied to the grouped values. We're going to aggregate the amount of people reached and the targeted number of people to reach from our monitoring data tab here. It's basically having Excel do the SUMIF function for us without having to type it in. So we'll be able to filter by region. Based on this, we'll create a bar chart that can also be filtered by region. To insert a pivot table, go to Insert, Pivot Table, from Table or Range. And now it's asking us for the location where we would like to place the pivot table, yes, in the existing worksheet. And the table and range that we want to select is in our tab Monitoring Data. And I am just going to select the first 3 columns here. Click OK. Now here on the right, you will see different pivot fields to be activated. I'm going to check off all 3. And now you will automatically see the sum of all 3 regions, which we already have learned how to do manually using the SUMIF function. Now I can also insert a bar chart based on this table. So I'm going to select the table, go to Insert, Pivot Chart, and it will now show me the values for each region. Now, when we select this table, you will see there's a new tab up here called Pivot Chart Analyze. And to create a filter, I go to Insert Slicer. And it will give me these buttons for filtering. I'd like to be able to filter by region. And now when I select only one of the regions, you can see that not only the bar chart automatically adjusts, but also the table up here. I can also select only 2 of them or all 3 here. I've removed all filters. Now we're back to all 3 again. If you have a data set and you're not sure what type of a pivot table would be the most useful and which values to place on the y-axis and which values to place on the x-axis, you can also have Excel. Well, this won't work with an existing pivot table. Let me go to our data source over here, and you can also ask Excel for pivot table recommendations. Now, this was just a very simple example of a pivot table. We wanted you to have seen the basics of how to set one up. There are many more options that you can play around with and discover. Next up, we're creating a little management cockpit using some of the things that we learned in this tutorial. Now, the purpose of this type of a summary is to have a very clean and lean look that just summarizes the most important insights that we've gained from processing our data without having too many distracting rows or columns of data. First of all, create a drop-down that will allow us to select a region. Now we're talking about the 3 regions here, Asia, Africa, and Latin America. Of course, as a source for the list of 3 regions, I could use our Comparison and Sums tab and down here select these 3. I'm going to create a little side calculation here, a side table in a light font though, because that will make things easier for the following exercises. So we have Africa, Asia, and Latin America. Now, do you remember where to find the drop-down menu? You go to Data, Data Validation, and allow List. The source are these 3 cells here. Now let's try it out. Wonderful, we can select all three areas. Next, we need a table that summarizes the number of people reached and the total expenses in the selected region. That means we want the sum of beneficiaries and the sum of expenditures to appear here for each of the regions that we choose in our drop-down menu. This is going to involve a SUMIF function where this cell is the criteria, but first we're going to copy and paste our results from the Comparison and Sums tab over here so that we can use this to refer to in our next SUMIF formula. So I'm just going to do some simple referencing and copy and paste these cells. Now we need to create a SUMIF formula that will show us the total amount of beneficiaries when the word Asia is selected up here, or Africa. So this cell is always going to be the criteria that we're going to be looking for in our little table over here. SUMIF this range contains this criteria. This is the same as under the traffic light tab. There is not going to be anything to add up because we only have each region once in this list. So it will always give us the respective value. There's nothing to sum up, but the formula will still give us the correct value. And now we can do the same for the expenditures. Let's try it out. It works. Next, create a top table from the sorted lists exercise. This is not going to be filtered by region because we haven't told Excel which countries are part of which region. This is just going to be simple referring to our sorted lists. I'm just going to do it for the first row. And because the table that it's referring to is dynamic, this will also automatically update if anything changes. Now create two bar charts that show the number of people reached and the total expenses in each region. We're going to select the data, insert 2D columns, we can remove the chart title because we already have the title here. And adapt the size. Now the same for expenditures. I'm going to hold the Control key down to select these columns that aren't right side by side. And here we go. Now I'd like to show you a real-life example of a monitoring tool that is a lot more elaborate than the little management cockpit that we just created, but still entirely possible to program using Excel and many of the functions that we just learned. This monitoring tool was developed to support a program which has the goal to sustainably improve the provision of modern energy services in selected countries, which is why here in the calculations you will see such things as solar, biogas, hydro, stoves, and there are many countries that were participating in this program, and you will see that we have a little drop-down box here, and depending on which country we choose, our overview changes. Now, you don't have to fully understand how all of this works. I just wanted to show you this as something to have. You're also allowed to download it, so you can have this for inspiration. These gray sheets aren't necessarily going to be of interest to you. These are just background calculations. Then we have country overviews with bar charts here on the side that also visually display the percentage of target achievement. We have some top 5 tables which show the most successful measures on the basis of one particular indicator, and they were implemented with the match and the large function, which we covered. The map in the overview here can actually be colored with the help of macros. We didn't cover macros here, but this way it is technically possible to show a dynamic thematic map based on an indicator. When you scroll down, you will see we have a line chart here that's been stripped of the x-axis and the y-axis. And here are some embedded diagrams based on data from different sheets. So this overview aggregates data from all of these other sheets. We can see here that we're using the sum-if formula again the same way, so that as we did in our management cockpit, so that the value here adjusts to the country that we chose. So I invite you to just click around, have a look. Don't try to understand everything here. Just take it as inspiration for what is possible if you want to create a monitoring tool using Microsoft Excel. We hope this tutorial was useful for you. If you would like to now try these exercises yourself, you can download the exercise file. It's the same one that I've been demonstrating everything with, and then download the solutions file or have a look at the video again to check your answers. You can find the download link in the description below. If any questions came up for you while watching this tutorial, or come up while going through the exercises on your own, or maybe even transferring what you learned to your own monitoring tool, you're welcome to join our webinar on Excel for M&E. It's a quarterly webinar that anyone can sign up for free, and we will be allocating time towards questions of our course participants. So you can go to energypedia-consult.com to find out more, or follow the link in the description. Thank you for participating. Good luck with your work, and perhaps see you in one of our webinars.